Welcome, Grey Fire pupils, to the next straight line examples. This time it's on altitude of a triangle. It's the exact same as perpendicular bisect. It's really important for you to know the definition of what an altitude is. An altitude has to come from a triangle, and we talk about the altitude from a vertex to the opposite side. And in particular, it is a vertex that meets the opposite side at right angles. The term altitude essentially comes from the height of the triangle. If you think of altitude of a plane, it would be from the plane directly down to the ground. So this vertical line will meet the horizontal line at right angles. Okay, so it's very important to know that definition. To be able to find the altitude of a triangle, we again think our point gradient equation. In this particular line, we'll always be given the point. We'll be given the point C in the example above. For our gradient, we will always have the coordinates of the points A, B. So what we're looking to do is to work out the gradient of the line AB, and then to get the gradient of the altitude, we would then work out a perpendicular gradient. And using the given point C, the perpendicular gradient, we can find the equation of our line. So working through an example, find the equation of the altitude from P in the triangle PQR. Going to do just a very quick drawing, just to give us an idea of what we're looking for. So 4, -2, -3, -1, and 1, 3. Should be a straight line triangle. So we have P, we have Q, and we have R. Find the equation of altitude from P. So from P, we'll go directly to the opposite side at right angles to QR. As it's an equation of the line we're looking for, as always, we're looking to use y minus b equals m x minus a. To be able to use that, we are looking for a point, and we're looking for a gradient. So again, thinking point, gradient, equation. Our point, we have our altitude goes through the point P. So P is 4, -2. Our gradient will come from the two other points that we've got, Q and R. And using our gradient formula, M, the gradient of QR, y2 minus y1 over x2 minus x1. So x and y of our first line, x and y of our second. So 3 minus 1 over 1 minus 3. Four over 4 is equal to 1. So for our perpendicular lines, we have M QR times by M perpendicular must equal to -1. So M perpendicular equals -1 itself. So looking at our equation, our point we were given is 4 minus 2. Our gradient, I'm going to just keep myself right here, M perpendicular is -1. And going through my equation or straight line formula, I'll get the equation of my altitude. So there's my A and my B. Y minus -2, -1, x minus 4, y plus 2, negative x plus 4. If we subtract 2 from both sides, y is negative x plus 2. Our equation. Again, for our second equation, I'm going to start with a triangle, just to keep myself right. Find the equation of altitude from L in the triangle LMN. So I have 3, 4. -2, 3. And -1, -3. L, M, and N. And it's from L. So our line comes down and would meet at a right angle. So once again, we're finding an equation in a line. An equation in a line involves y minus b equals m x minus a. When I need a point, I need an equation. I need a gradient. So if it is an altitude from L, my point I have, L is 3, 4. My gradient, if it's from L, I need my gradient of Mn. Using my gradient formula, labelling my points to keep myself right, Mn, x and y of my first, x and y of my second. -3, -3, -1, -2. So -6 over 1 is -6. And that's my gradient of Mn. My altitude is perpendicular to this, so for the gradient of Mn, multiply by the perpendicular to equal to -1. Then M perpendicular will be -6 over 1, will flip to become 1 over a +6. So I now have, for my altitude from L, I have a point that we go through, it's 3, 4. I have my perpendicular gradient, which is a 6th. and my straight line equation y minus 4 is a sixth x minus 3. In this situation, I do not like my fraction, so let's get rid of that by timesing 6 by both sides. 6y minus 24 is 1 lot of x minus 3. 6y minus 24 is equal to x minus 3. 6y is equal to x. Add 24 onto both sides, plus 21. And my equation of my altitude. Again, additional wee fact, orthocentre is where the three altitudes in a triangle would meet. If you work out your two altitudes and you're then asked to find the orthocentre, you're able to find that by simultaneous equations, as we'll find out in later notes. Task, as always, is part of the PowerPoint.